So example 1 just kind of pushes you off the deep end. It just starts off by saying, find an equation from this graph. Oh, well, it sounds scary, but it's actually pretty easy because you already know that P and Q are the vertex coordinates, so you just plug them in. And then there's a little bit of a trick to finding A, but it's not a big deal. All you really need is your vertex and one other point. So we'll start by writing out y equals A times x minus P, and then we're just going to fill in the values for P and Q. So we can see that P, so I can write down my vertex point. My vertex is 3 and 2. So y equals A times x minus P squared plus Q. And if we'll just color code these a little bit. 3 and 2. So the 2 just goes here where the Q is. And the 3 just goes right here. Now if that had been a negative, if this had been a negative, I'd have had to change this sign because minus a negative is a positive. But since it's just positive, I just slip it right in there and it's done. Now, all we have to do is find A and we're good to go. We find A by remembering that any other point on the line is x and y. So, if I look at this point, it's 5 and 4. Well, that's my x and that's my y. So that means if I go back over to this formula, I can take this x out of here and put in 5 because that's my x. That's what these numbers mean. And I can get rid of my y and put in 4 because that's what that y meant. It meant that if I put in x, I get 4 out. Put in 5 as x. I get 4 out. So now I have my x and my y into my formula and I can just solve it. I'm going to get rid of the colored markers. And 4 equals A times 5 minus 3 is 2, squared is 4, plus 2. Now the reason I wrote it like this is because the A and the 4 are stuck together. Bed mass, right? So I got to take my 2 over to this side as a minus 2, which means I'm going to have 4 minus 2 equals A times 4, or you could write it 4A if you wanted to. 4 minus 2 is 2, so I can make this look like that, a little tidier. I want to get rid of this. I'm multiplying it on this side, I have to divide it on this side. So that's going to get rid of it, and it looks like A is 2 over 4. We know that you can reduce that, so, well, let's just put it here. 1/2 equals A. I already know that my 3 and my 2 are part of my equation. So now I'm just going to write my final equation as y equals 1/2 times x minus 3 squared plus 2. So you can see that I've got my A right here. I've got my 3 from here, and I've got my 2 from here. So it's really pretty simple. You throw in your vertex points in P and Q, make sure you're paying attention to the signs, and then you throw in one extra point on the graph. Didn't matter, I could have picked this one, this one, this one, whatever, I just chose that one. You put them in for x and y. That will give you a formula where all you have left unknown is A, which means you can just solve for A, and that's how we get A. Put it back into the original formula, and you're good to go. You want to check it out? Use your graphing calculator and punch it in. So we can hit our y equals button, and we can go, I'm just going to hit 0.5 times bracket x minus 3, close bracket, squared, plus 2, graph it, and I should get a graph that looks like that. And ta-da! Look at that. It's practically identical. Amazing.